In a 200 amp electrical panel that already contains 10 tandem breakers, it is not permissible to install any additional tandem breakers. This restriction is primarily based on safety considerations and adherence to electrical codes such as those established by the National Electrical Code, or NEC. Understanding the limitations of your electrical panel is crucial to preventing overloads and ensuring the safe operation of your home's electrical system. Firstly, it's essential to understand what a tandem breaker is. A tandem breaker, also known as a double or twin breaker, is designed to allow two circuits to be placed in a single breaker slot within an electrical panel. This is achieved by using a breaker that has two separate switching mechanisms within the same physical space as a standard single-pole breaker. Tandem breakers are often used to increase the number of circuits available in a panel that has limited physical space. Secondly, the NEC and other local electrical code set limits on the number of circuits that can be installed in an electrical panel. These limits are based on several factors, including the panel's ampacity rating, the physical space available for breakers, and the heat dissipation capabilities of the panel. Exceeding these limits can lead to dangerous conditions such as overheating, arcing, and even electrical fires. Thirdly, it is important to note that while a 200 amp panel has a certain number of breaker slots, not all of these slots are necessarily designed to accept tandem breakers. Some panels may have only a limited number of positions that are specifically designed and rated for tandem breakers. Installing tandem breakers in slots that are not designed for them can compromise the panel's ability to safely distribute power. Fourthly, the total load on each circuit and the panel as a whole is a critical factor in determining whether additional breakers can be added. Even if there are available breaker slots, adding more circuits could potentially overload the panel's main breaker or individual circuit breakers. Overloading a breaker can cause it to trip frequently, which is inconvenient and can also damage the breaker over time. More seriously, sustained overloading can lead to overheating and electrical fires. Fifthly, before making any changes to your electrical panel, it is essential to consult with a qualified electrician. An electrician can assess your panel's current load, determine whether it is safe to add more circuits, and ensure that any new installations comply with all applicable electrical codes. They can also advise on alternative solutions if adding more breakers is not feasible, such as upgrading to a larger panel or installing subpanels. Sixthly, the panel's labeling plays a crucial role in determining the allowable number of tandem breakers. Many electrical panels have a diagram on the inside of the panel door that indicates which slots are approved for use with tandem breakers. This diagram may show that only specific positions in the panel are designed to accommodate these types of breakers. Ignoring this labeling and installing tandem breakers in unauthorized slots can void the panel's warranty and create safety hazards. Seventhly, consider the total number of circuits currently served by the panel. Each circuit, whether protected by a standard breaker or a tandem breaker, adds to the overall load on the panel. If the panel is already serving a large number of circuits, even if the total amperage draw is within the panel's 200 amp rating, adding more circuits could still strain the system and increase the risk of overloading. Eighthly, it is also important to consider the types of loads that are connected to each circuit. High-demand appliances such as air conditioners, electric heaters, and electric stoves draw a significant amount of power and can quickly overload a circuit. If you are planning to add new circuits for high-demand appliances, it may be necessary to upgrade the panel to a higher amperage rating or install a separate subpanel to handle the additional load. Ninthly, the physical condition of the electrical panel should be assessed before adding any new breakers. Check for signs of corrosion, damage, or overheating, such as discoloration or melting of the breaker housings or wiring. If any of these issues are present, it is essential to have the panel inspected and repaired by a qualified electrician before proceeding with any further modifications. Tenthly, when dealing with electrical systems, safety should always be the top priority. Working with electricity can be dangerous, and it is crucial to take all necessary precautions to prevent electrical shock or fire. Always turn off the power to the panel before working on it, and use appropriate safety equipment such as insulated tools and gloves. If you are not comfortable working with electricity, it is always best to hire a qualified electrician to do the job. In summary, adding more tandem breakers to a 200 amp panel that already has 10 installed is generally not recommended and may not be permitted by electrical codes. It is essential to consult with a qualified electrician to assess your panel's current load, determine whether it is safe to add more circuits, and ensure that any new installations comply with all applicable codes. Always prioritize safety when working with electrical systems, and never attempt to exceed the limitations of your electrical panel. Understanding these principles and adhering to safety guidelines will help ensure the safe and reliable operation of your home's electrical system. Consider the specific design and manufacturer of your electrical panel. Different panels have different configurations and limitations regarding the use of tandem breakers. Some panels may be designed to accommodate a higher number of tandem breakers than others. Always refer to the manufacturer's specifications and labeling for your specific panel to determine the allowable number of tandem breakers. Evaluate the age and condition of your electrical panel. Older panels may have deteriorated over time, which can compromise their ability to safely distribute power. If your panel is old or shows signs of wear and tear, it may be necessary to replace it with a newer model that is better suited to handle your electrical needs. Consider the future electrical needs of your home. If you anticipate adding more electrical appliances or devices in the future, it may be wise to upgrade your electrical panel to a higher amperage rating to accommodate the increased load. This can help prevent overload and ensure that your electrical system is capable of meeting your future needs. Review the local electrical codes and regulations in your area. Electrical codes vary from one jurisdiction to another, and it is important to comply with the specific requirements in your area. Consult with a local electrical inspector or a qualified electrician to ensure that your electrical panel installation meets all applicable codes and regulations. Inspect the wiring connections within the electrical panel. Loose or corroded wiring connections can create resistance, which can lead to overheating and electrical fires. Ensure that all wiring connections are tight and secure and that there are no signs of corrosion or damage. Clean the electrical panel regularly to remove dust, dirt, and debris. Dust and debris can accumulate inside the panel and interfere with its operation. Use a vacuum cleaner or a soft brush to gently clean the panel and remove any contaminants. Be careful not to touch any of the electrical components while cleaning. Check the circuit breaker ratings to ensure that they are appropriate for the circuits they protect. Circuit breakers are designed to trip when the current exceeds a certain level. If the breaker rating is too high for the circuit, it may not trip in time to prevent an overload. Ensure that all circuit breakers are properly sized for the circuits they protect. Monitor the panel's overall load to ensure that it does not exceed its rated capacity. Use a clamp meter to measure the current flowing through the panel's main breaker. If the current is consistently close to or exceeds the panel's rating, it may be necessary to upgrade the panel to a higher amperage rating. Keep the area around the electrical panel clear and accessible. Do not store boxes, furniture, or other items in front of the panel, as this can make it difficult to access in an emergency. Ensure that there is always a clear path to the panel in case you need to shut off the power quickly. Educate yourself and your family about electrical safety. Learn about the potential hazards of electricity and how to prevent electrical accidents. Teach children never to touch electrical outlets or appliances with wet hands, and always supervise them when they are near electrical equipment. By following these tips and guidelines, you can help ensure the safe and reliable operation of your electrical panel and protect your home from electrical hazards. Remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician if you have any questions or concerns. The National Electrical Code, or NEC, provides comprehensive guidelines for the safe installation and operation of electrical systems. It is updated every 3 years to reflect the latest technological advancements and safety standards. Familiarize yourself with the NEC requirements that apply to your electrical panel and ensure that your installation complies with these standards. When selecting circuit breakers for your electrical panel, choose high-quality breakers that are listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, or UL-listed breakers have been tested and certified to meet industry safety standards, and they are more likely to perform reliably in the event of an overload or short circuit. Consider using arc fault circuit interrupters, or a size to protect circuits that serve bedrooms, living rooms, and other areas where electrical fires are more likely to occur. ASIs are designed to detect arc faults, which are a common cause of electrical fires, and to trip the circuit breaker before a fire can start. Ground fault circuit interrupters, or GFCIs, are essential for protecting circuits that serve wet locations such as bathrooms, kitchens, and outdoor areas. GFCIs are designed to detect ground faults, which can cause electrical shock, and to trip the circuit breaker before a person is injured. Regularly test your ASIs and GFCIs to ensure that they are working properly. Press the test button on the device to simulate a fault condition. The breaker should trip immediately. If the breaker does not trip, it may be faulty and need to be replaced. Use surge protectors to protect sensitive electronic equipment from voltage spikes. Surge protectors are designed to absorb excess voltage and prevent it from damaging computers, televisions, and other electronic devices. Install surge protectors at the electrical panel and at individual outlets to provide comprehensive surge protection. Avoid overloading extension cords and power strips. Extension cords and power strips are designed to provide temporary power to devices that are not located near an outlet. However, they are not intended to be used as permanent wiring, and overloading them can create a fire hazard. Use extension cords and power strips sparingly and never exceed their rated capacity. Be aware of the signs of electrical problems such as flickering lights, burning smells, and hot outlets. If you notice any of these signs, have your electrical system inspected by a qualified electrician. Ignoring electrical problems can lead to more serious problems down the road, including electrical fires. Keep electrical cords away from heat sources, such as stoves, radiators, and space heaters. Heat can damage electrical cords and cause them to short circuit. Ensure that electrical cords are properly insulated and that they are not frayed or damaged. Never run electrical cords under rugs or carpets, as this can trap heat and create a fire hazard. Use cord protectors to protect cords that run across walkways or doorways. Cord protectors are designed to prevent people from tripping over cords and to protect the cords from damage. If you are planning to do any electrical work yourself, be sure to obtain the necessary permits and inspections. Electrical work is regulated by local building codes, and it is important to comply with these codes to ensure the safety of your home. In addition to the number of tandem breakers, consider the total number of circuits allowed in the panel. Electrical panels are designed with a specific number of circuit slots. Even if a panel has space for more breakers, it might be limited in the total number of circuits it can safely support. Exceeding this limit can lead to overcrowding, difficulty in wiring, and increased risk of electrical hazards. Panel fill calculations are used to determine the maximum number of circuits allowed in a panel based on its size and design. These calculations take into account factors such as wire fill capacity, heat dissipation, and accessibility. Consult with an electrician to perform a panel fill calculation and ensure that your panel is not overloaded. Breaker spacing and layout are important factors in electrical panel design. Breakers should be spaced adequately to allow for proper ventilation and heat dissipation. Overcrowding breakers can restrict airflow and cause them to overheat, which can lead to premature failure and potential fire hazards. Ensure that breakers are arranged in a neat and organized manner, with adequate spacing between them. Consider the use of surge protection devices, or SPDs, to protect your electrical panel and connected appliances from voltage surges. SPD are designed to divert excess voltage away from sensitive equipment, preventing damage from lightning strikes, power fluctuations, and other electrical disturbances. SPD can be installed at the main electrical panel or at individual outlets to provide comprehensive surge protection for your home. Consider energy efficiency when making changes to your electrical system. Energy-efficient appliances and lighting can reduce your energy consumption and lower your electricity bills. When replacing old appliances or lighting fixtures, choose models that are Energy Star certified to ensure optimal energy performance. Consider the use of smart home technology to monitor and control your electrical system. Smart home devices, such as smart thermostats, smart lighting, and smart plugs, can help you manage your energy consumption and improve the safety and security of your home. These devices can be controlled remotely via smartphone or tablet, allowing you to monitor your electrical system from anywhere. Remember to keep your electrical panel properly labeled and updated. Clearly label each circuit breaker to indicate which devices or areas of the house it controls. This will make it easier to identify and troubleshoot electrical problems in the future. Update the labels whenever you make changes to the electrical system. Regular maintenance and inspections are essential for ensuring the safe and reliable operation of your electrical system. Schedule periodic inspections by a qualified electrician to identify and address any potential problems before they become serious. Regular maintenance can help extend the lifespan of your electrical panel and prevent costly repairs. Finally, remember that electrical work can be dangerous and should only be performed by qualified professionals. If you are not comfortable working with electricity, it is always best to hire a licensed electrician to do the job. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and correctly, ensuring the safety of your home and family.